In this lecture, we'll talk a little bit about, continue a little bit about the board and the microcontroller and its properties, but then we'll start talking about the IDE itself. So that's the software environment that you use to actually do the coding and compile the code and upload the code. So first about the microcontroller. Over here we've got a bunch of data about the microcontroller. So just some statistics, high-level information about the microcontroller that you would find at the beginning of any data sheet about this microcontroller. So it's the Atmega 328. It's an 8-bit microcontroller. Operating voltage is at 5 volts, so its pins are going from 0 to 5 volts. The input voltage recommended and the input voltage limits. So what those are is if you're driving it with external power, what voltage would you want to supply to it? So you want to give it 7 to 12 volts, but that's preferred. And what it does is its operating voltage is at 5 volts, so it'll step that down. But you want to give it in the range of 7 to 12 volts if you're going to do that. Not through the USB, but through external input. Digital I/O pins, it's got 14 digital I/O pins, numbers 0 through 13. Analog input pins, it's got 6 analog input pins at A0 through A5. DC current per pin and DC current on the 3.3 volt pin. So DC current, why that matters is because basically what that says is how much current can be supplied out of that pin. So the Arduino can only drive a certain amount of current out of a pin because it's a small device. It only can push a certain amount of current. So like say the DC current for an I/O pin is typically 40, the max is 40 milliamps. That's not a lot. And that's important to know because that tells you, that limits what you can drive. So for instance, if you're turning on an LED, 40 milliamps is fine. In fact, you can only push maybe 20 milliamps through an LED before you fry the thing. But if you want to drive a motor or something like that, 40 milliamps is not. So you need, if you want to drive a motor, you've got to do something else. Actually, we'll talk about that later in the next course. So flash memory. Flash memory is, let's see, it's non-volatile storage. I happen to have one right here. It's what you would find in something like this, right? Any thumb drive, right? That's flash memory. It's non-volatile memory. And the Atmega 328 actually has some flash memory. All processors have some kind of flash memory, and that's where you store the programs that you run. So non-volatile memory means that it stores it and holds its data even if it loses power. So that thumb drive I just showed you, you unplug it, it's unplugged from power right now, but it's storing its data, it's holding it. So that's what you want for your program. So your programs go into flash memory, and it's only got 32 kilobytes of flash memory, which is not much at all, but it's enough for what we're doing. SRAM is just, that stands for static read-only memory, random access memory, random access memory, static random access memory. And that is it's just regular memory, but it's volatile memory. So what that means is when you turn off the power, anything in SRAM disappears. And so when you power it on again, you've got to reload SRAM. So SRAM is the memory that uses at runtime, and 3 kilobytes, which is not much. EEPROM, very little EEPROM, only 1 kilobyte. EEPROM is like flash, but different. It's controllable in individual bytes rather than whole blocks. Very little of it. And clock speed is 16 megahertz, so it can do, say, roughly 16 million cycles a second, so 16 million operations in a second. And so that's slow compared to a desktop, which might be 3-4 gigahertz, but it's plenty fast for the type of things we want to do. And an 8-bit processor like the Atmega 328, that might cost you $1.50, say, that ballpark. If you wanted to buy an individual processor, it might cost you $1.50. The board itself, the whole Arduino board, costs $40, maybe less, $35. You can get it a little cheaper on Amazon or something like that. But the board has a lot of other stuff on it, and it's much more convenient to use. If you just get the bare chip, you can't program it directly. You need a programmer and all this, where the board gives you all that. So these things are pretty cheap. All right, so let's take a look at the IDE, so Arduino Integrated Development Environment. So an IDE is a software tool that you use for programming. So the main thing in here, actually, if you look at the IDE, the main window right there is a text editor for writing code. So you put your code right in that text editor, and you can type it in there. And right now, we just got a simple shell in there, but you can type whatever code we want into that text editor. Now, above that, it's got the menu, the menu items, the file, and all this to say, regular commands, save file, open file, that sort of thing. All the commands are in those menu options, but underneath that there are these buttons where you have the most common options in there. So the most common operations they put in the form of buttons. But if you want to look at every operation that you could do, you can look through the menus and find every operation. But the buttons are the most important. And then at the bottom is a message area. And that message area, it's usually for error messages. So when you're compiling, you get some kind of an error, it puts it in the message area. So this is the basic IDE, what it looks like. And you're going to download this from arduino.cc and install it and run it. And when you double click and you run it, you'll get a window that looks something like this. Now, just to go over the main functions, so the buttons. The buttons have the most common, most useful operations. So those buttons across the top row, here's what they are. First, there's a verify button, a little check, that compiles the code. And checks, in the act of compiling, it checks for errors. If there's an error, it's detected on the compile. So often you'll want to compile your code, verify, they call it verify, but you're compiling the code to see if it's it doesn't completely check that it's correct. It just checks that there are no compile errors, right? If there's a compile error, a syntax error, something like that, then it'll be caught in the verify. Now, upload compiles the code and uploads it to the board. So it does both in one fell swoop. Now, so upload can only work if you have the board connected. You can verify the code without connecting the Arduino to your desktop, laptop, but for upload, you've got to have it connected. New creates a new sketch, a new program. Open opens an existing, saves a sketch to a file in a directory of your choice. And serial monitor opens a window to communicate with the board. We'll get into more of this later in the next course. Actually, later on in this course, we'll get into what the serial monitor does. But the idea is it opens a separate window. So one limitation of Arduinos and embedded processors in general is that they don't have screens, right? A desktop laptop has a screen and a keyboard, right? So it's very easy for you to send data in and read data out through the screen and the keyboard. But an embedded device does not. The Arduino, it doesn't. All it has is a couple of LEDs sitting on it and some pins. So if you want to send data to it, you want to type data to it or read data from it, like on a screen, you can't do it directly. So that's what the serial monitor is for. It's a monitor, you start it, and it'll open up a window on your machine, and it allows you to type text and send it straight to the Arduino. Also, the Arduino can print stuff on the screen for you, and you can see it in this serial monitor window. So we'll use that later on in the course. Actually, in the next module, we'll talk about that more. Thank you.